In the next few minutes, we are going to talk about geospatial AI. It's a very unique type of artificial intelligence. It's actually built for you, designed to help you solve geospatial problems and to help you show the world the power of maps and geography. Geospatial AI is already transforming ArcGIS, making it easier with AI assistance, more powerful with new AI tools and models, and impactful with AI agents. We are going to talk about all of this. AI assistants embed the power of generative AI within the user experience of ArcGIS. These assistants are going to help you with everyday workflows, configuring maps, apps, automating tasks, and even coding. 3 things to remember. AI assistants are included with user types at no additional cost. Through a new role privilege, administrators will be able to control who in your organization can use these assistants. Assistants are available in online already now, and they are coming into enterprise before the end of the year. Now, we are going to see 3 demonstrations. So please welcome Stella Meserve and Paulina Menev.
Thanks, Ishmael. Today, we're going to show you 3 assistants: ArcGIS Pro, Notebooks, and Item Details. We'll start in Pro and take a look at how the assistant can help us build charts, run analysis, and change symbology, only using natural language. New York City is full of bike rental stations. We want to visualize patterns of where people rent bikes and where they drop them off. These are the origin and destination pairs for each ride. We'll focus on the top 10 most utilized station from last month and where each trip ended. But when the trips are displayed on the map all at once, it's overwhelming. Let's use the new AI assistant in ArcGIS Pro to help us understand patterns across the data. We'll use actions. Actions help us perform tasks like filtering and finding geoprocessing tools, simply using natural language. Like this. Create a bar chart of the count of station names in the origin-destination pairs layer. The assistant considers our question and builds the chart for us. And looking at the chart, the West 21st Street and 6th Avenue station has the highest number of rides. Let's learn more about this station and tell our assistant to do some analysis. We'll ask it to count recurring origin-destination pairs. The assistant looks through the thousands of geoprocessing tools, populates the parameters, and in this case, we're able to review it before running it. It found the Count Overlapping Features tool, which will aggregate all of the start and end station pairs that are the same. Dark blue lines show higher counts. So let's tell our assistant to symbolize station pair trips. So features with 45 or fewer trips are 90% transparent. We want higher usage to stand out on the map, and this visualization highlights the most common travel patterns. And now that we know the workflow, we can apply it to other popular stations and explore similar visualizations for citywide patterns. And that's just a few examples of what the Pro Assistant can do. Next, we're going to take a look at a couple more assistants, starting with the new scripting assistant in Notebooks. Notebooks are an efficient way to write, document, and run code all in one place. We'll use the assistant to help us create, explain, and learn code. Let's continue to analyze city bike patterns and tell the assistant to write a script to fetch city bike station data, calculate utilization for each station, create a feature layer, run a hotspot analysis, and return the results on a map. City bike station data is accessed through an API that provides real-time information on bike and dock availability. And now, we have a complete block of code. Let's add it to the notebook. Typically, we would review this before running it, but for now, let's just hit run and see what happens. The assistant generated comments to explain the steps being taken. It independently identified 2 API URLs, one for station location, one for station status. And I didn't even have to tell it where to look. That's pretty cool. Let's take a look at the station status URL. I don't know about you, but my first reaction was honestly, yikes. An API response is difficult to interpret, particularly for those who are unfamiliar with the data structure, or, in this case, the bike share system. This response would have to be evaluated to identify key operational metrics like station capacity and other variables. In this case, the assistant does the interpretation for us, identifying the fields we need and creating a feature layer in our contents. Next, the assistant calculates utilization, identifies the required module, and executes a hotspot analysis. Finally, the results show red hotspots indicating high usage and blue cold spots with low usage. These results can be visualized on a map in a matter of minutes, making it easy to integrate data from other systems, like an API, and run analysis. Even for those who are unfamiliar with Python, the ArcGIS Notebook Assistant makes it easy to create and learn code without ever leaving the notebook. Thank you.
And now, we've saved your favorite topic for last. Good old metadata. Let me show you a new assistant that's going to make it so much easier for you to work with metadata. When we publish a layer to ArcGIS Online, it should have a good summary and a good description. We all know that this is something we should do, and we all know that writing this metadata can take a whole lot of time. Let's see how we can speed it up. This new Suggest button is an item details assistant. It reads your layer and drafts everything for you, returning the suggested text so that you can review, approve, and save in just a matter of seconds. And now we have our updated summary and description populated with the informed context based on our data. We also need to provide our fields with more data for people and AI to understand. So that's why there's also a Suggest button for fields that automatically created these improved display names, descriptions, and field value types. For example, the assistant created this description for the bike type field, explaining the type of bike used on each trip. And for start station name, it also recognized that this field is a location or place name. You're going to save so much time using the new item details assistant. Thank you.
Thank you, Paulina. Thank you, Stella. ArcGIS includes ready-to-use GeoAI tools and models. With them, you can work with different types of data, imagery, 3D, text, and more. Now, today, we want to share with you a very exciting project, a new foundation model. We call it the Geospatial Vision Language Model, or GoVLM. We are building it in partnership with Amazon Web Services, They are providing the cloud infrastructure. To train this model, we are using massive amounts of geospatial imagery all across the globe. And it has two key characteristics. The GoVLM, first of all, understands geospatial imagery, obviously, but also language. And this enables prompt-based analysis. GeoVLM also handles multiple types of tasks: pixel classification, object detection, counting objects, describing imagery. One model, multiple tasks. So now we're going to see a demonstration to see what this model is capable of.
Welcome to Belize. Let's go to Hopkins, a Garifuna village on the coast. Here, we've collected new drone imagery, and we want to build out our foundational geospatial layers for Hopkins. Soon, we will release GeoVLM in beta. This single model can be used with our deep learning tools to run feature detection, description, and classification all over the world using natural language. GeoVLM responds to a wide range of prompts. Let's start by detecting trees across the imagery. Within minutes, we can generate results for the entire village, first detecting trees, and then we can do the same for buildings and roads, creating our foundational data from scratch. And this model isn't limited to a specific geography or imagery. It works globally. Here in urban Las Vegas, we can use the same prompts to detect trees, buildings, and roads using the World Imagery Base Map. And using the same model, we can also interrogate our imagery by asking it to describe what it sees. For these crop circles, we'll prompt it to classify fields into crops, fallow, or mixed. The model interprets what is in the imagery and enriches our crop circle data. So instead of relying on task-specific models, GeoVLM enables you to perform many deep learning tasks, offering you a much more flexible and scalable approach to analyze your geospatial imagery. Thank you.
Okay, new concept, agentic mapping apps. The idea is simple. It's really a conversational experience on top of a map. This is so non-technical users can more easily query information out of GIS, all through a natural language experience. To build this type of applications, you start with a web map. The layers in the map really determine the scope of the application, the type of questions that your application will be able to answer. Once you have the map, you can choose to either configure it with the new Data Explorer Instant App template, or you can use the developer SDK. These type of user experiences are powered by a collection of geospatial agents. They all work together. ArcGIS ships with out-of-the-box geospatial agents for data exploration and navigation, but of course, you can create your own as well. These agents connect to both large language models for reasoning, as well as your own GIS services to fetch the data they need and to use your authoritative tools from ArcGIS. So next, we're going to see in detail how these applications work.
Aloha. Welcome to Hawaii. Here's an example of a web app I created using the Data Explorer Instant App template. Using natural language, we can explore facilities, readiness conditions, and community information across the islands. We'll call it the Hawaii Logistics Preparedness Explorer. Using the chat on the left, we can ask questions about the map in this app, starting with what layers are available in this map and what does each one help us understand. It gives us a quick overview of what's in the map and why each layer matters, helping us to explore with more context. And with the Hawaii Preparedness Assets layer, we can ask a simple map filtering question. Show which fuel depots on Oahu have less than 2 weeks of supply. Name the facilities. This helps us quickly focus on the assets that may need review by filtering the map to the relevant facilities and providing the information in a table, ranking them by our attributes. And Data Explorer can also answer location questions and bring together information across multiple layers. Show the district that Honolulu West Fuel Support Facility is in on the map and report its population and the demographics. This turns a simple asset question into a decision support workflow, enabling us to move from where is the problem to who could be impacted by a fuel supply disruption and where should we focus first. And Data Explorer also has guardrails. So if I ask a question that's not about the map, such as, should I go on vacation here? It will inform us that it needs to stay focused on the authoritative data in the map and only follow GIS relevant workflows. The Data Explorer Instant app is an agentic template for your maps, broadening the impact of your work by helping wider audiences interact with your data in a simple, guided way. Thank you.
That was awesome. Thank you. Look, independent from the work that we do with GIS, organizations these days are looking to leverage AI agents to support business operations. Technological advancements in the world of agentic AI are happening fast, they are promising, they are exciting. But we have to acknowledge that these general purpose agentic frameworks are just not geospatial intelligent. If the agents of the future are going to make decisions in the absence of geographic context, I just wonder where all of this is going to take us. So here's what I have to say, and it is that AI needs GIS. Make yourself a t-shirt, a coffee mug, that let the world know that AI needs GIS. Now, the good news is that you already have the geographic knowledge and the tools and the data. They are in ArcGIS. So all we really need is to bridge that gap. Through standards like Model Context Protocol, this is actually very easy to use. And that is exactly what the next demonstration is going to show.
Lately, many of us have been using agents in our day-to-day work. A common application is Microsoft 365 Copilot. Within Copilot, we can add custom agents. For instance, this permitting agent, which was created to help answer questions about the permitting process, like, what do I need to keep in mind when applying for permits in Hawaii? In a couple of seconds, it informs us that land use, environmental regulations, and local processes are important considerations. Next, let's ask, what is the status of the Kihei Logistics Center permit? This information is in ArcGIS, which the agent does not have access to yet. So let's switch to Copilot Studio, a platform for building custom agents. Because Copilot supports MCP out of the box, we can easily connect it to ArcGIS. This equips the agent with an additional set of tools that enable it to discover content in our portal, run analysis, and query data. In the test pane, let's re-ask the same question now that the connection has been established. With MCP, the agent has access to our portal. It identifies and queries the correct proposed projects layer, and shortly, it'll inform us of the project status. Pending review and environmental approval. Permit evaluations require geographic analysis. We've implemented this process through a geoprocessing model that is now available to our agent. So let's run a permit evaluation. On the left, the agent identifies that model and runs it. And once it's done executing, we'll receive a report identifying the screening layers that intersect our proposed project's boundary. For instance, the flood hazard areas and lands designated within the Federal Protected Areas database. The workflow also provides a direct link to a map, so we can easily validate the results. MCP enables agents to gain geospatial intelligence, connecting ArcGIS to your everyday business tools and workflows. Thank you.
Well, as you can see, there is a lot going on with Geospatial AI in ArcGIS. We really hope that you use the rest of the week to learn much more. Thank you.